Hi guys, now we are going to see about a hot tensile test, which is related to our normal tensile test. In that we have going to, in the normal tensile test we are taking a dog bone specimen which looks like this. In this dog bone specimen we are going to kept in a UTM machine. In that UTM machine there are two grips, the lower grip and the upper grip. In the lower grip where it is fixed in the UTM machine, and the upper grip we are going to give a load in that, and when we are giving a load it will first undergoes elastic deformation. After that it will undergoes a plastic deformation, and then it will lead to the fracture. During this the length of the specimen increases and the cross sectional area of the specimen decreases, and during when the load exceeds maximum limit, the fracture will occur, whether it may be ductile or brittle fracture. Mostly ductile fracture may occur. For this normal tensile test we are going to we are able to find the elongation, percentage of reduction, and yield stress, and we can also put the diagram for a stress strain curve like this. In this we have get the stress strain curve like this. We can get a stress strain curve like this. In this, where this is the yield point, and up to this the elastic deformation will occur. In this yield point there are three regions are there, where the proportional limit, elastic limit, and the yield point. And after that, after the yield point means after that yield point plastic deformation will occur. After that plastic deformation, when the maximum load, at the maximum load the ultimate tensile strength, which means the necking will occur at this stage. After that necking, the fracture will going to occur in that specimen. This is the stress strain curve for a normal tensile test. And also now which is a hot tensile test which is similar to the normal tensile test, but we are including a temperature in this. Hot tensile test which is performed at elevated temperature, about 0.5 tm. Tm means melting temperature. This is a melting temperature which is done in hot working conditions. It is also important for the metals and alloys. Why we needed a hot tensile test? Through the tensile test we can measure the elongation, reduction, and other things and all. No, why we have to understand the mechanical behavior at high temperature also. For example, we are taking turbine blades, we can make it, but in the temperature, whether it can the applications which is in a high temperature or low temperature, we should know the materials which behave in a high temperature, which can behave what it can be behavior in a low temperature, so that we are doing a hot tensile test. To design hot rolling, it is also example for the hot rolling, forging, and extrusion process. To prevent crack during hot working, to prevent crack, the hot tensile test is needed. And also for safe working temperature range, when the we have to know the temperature range, no, during the hot conditions. So only hot tensile test is using. In this the principle of the hot tensile test, where the strength decreases with increase in temperature, and then with increase in temperature the ductility also increases. Ductility increases means the toughness also will increases. Automatic mobility, yeah, I told ductility also increases, which also indicates the mobility. Atomic mobility also increases at high temperature. This dislocation movement gets easier when the strength decreases, and during the strength the atoms which is bond very tightly to each other. But when we are putting that specimen to a high temperature, the atom will move other another space, so it will get free upon spacing. Then large plastic deformation also occurs. Usual tensile test, plastic deformation occurs, but in a high temperature there is a large plastic deformation occur. And the setup which we have taken for a hot tensile test is a tensile testing machine, which is a UTM machine, ultimate tensile testing machine, high temperature furnace. The dog bone specimen which we are going to kept in a UTS machine with a furnace, which the furnace will be preheated, and then the specimen we are going to keep. And the procedure for the hot tensile test, I have already said that a prepared standard tensile specimen should be taken. Standard ASTM standard, maybe usually we will take the cylindrical or flat tensile specimen. Place specimen inside the furnace, heat to the required temperature, maintain uniform temperature. Uniform temperature is very important. Then they will segregate. If the temperature is not uniform, then the particles, we are going to microstructure, the particles will segregate, then micro segregation will occur, and then coring, it will goes on. So uniform temperature is very important. Apply tensile load at controlled strain rate. Yeah, the strain rate should be controlled when applying the tensile load. Record stress strain data until fracture. Then only we know how was the plastic deformation, how was the elastic deformation, so that we are going to draw a stress strain data. Okay. Then stress strain curve at high temperature. How will be the stress strain curve at high temperature? We already see the stress strain curve, which is only for the room temperature. It is only applicable for a room temperature, not applicable, which means we have get this curve in a room temperature specimen. But here we are going to keep in a high temperature specimen. High temperature specimen, we don't get a clear yield point, which is very smooth here. We does not get a sharp point like this and like this. We will get a smooth yield point. We didn't find a correct yield point, so there is a no clear yield point. Flow stress also low. As I already said that it has large plastic deformation. Possibly steady state flow region also occur. During this we are testing this, what we have got as a result, we can get a flow stress, hot ductility. As I before said, we can test the ductility. When during this, the ductility of the material increases and the strength of the material decreases. Then we can note the fracture behavior. When the fracture occurs, the behavior may be elastic or a plastic, maybe it has a strength or a ductility. We can measure these also. Then the stress strain curve, as I said before. And application, where we can use this hot tensile test. Why we are doing? To apply in a hot rolling, forging, extrusion, high temperature alloy design, process parameter optimization, and also in a turbine blades, which may undergoes different temperature regions. For that we are using a hot tensile test. And what are the advantages in the hot tensile test? Okay, simulates actual hot working conditions. Actual hot working conditions, it is a main advantage, because normal tensile test does not related with temperature, but this hot tensile test always related with temperature about 0.5 Tm, which is also used for the recrystallization. Simple test compared to industrial trial. Yeah, definitely useful for material selection. Yeah, if I am taking a material which does not, for example, I am saying which does not withstanding 0.3 Tm also, when another material withstanding a 0.5 Tm, which I can prefer the second specimen. So the material selection, it is easy for us. helps avoid hot cracking. As I said before, when the first specimen and the second specimen which have a less hot cracking, I will prefer that specimen. That's it. And then the limitations. What are the limitations we are going to see in the hot tensile test? First one, oxidation. The specimen does not go oxidation process because we are doing at a high temperature. So the specimen does not go oxidation. Temperature control is difficult. Yeah, we have to maintain the uniform temperature. Uniform temperature control is very difficult in the furnace. Necking limits strain, and then not suitable for very large strain studies. Yeah, and we are giving a constant strain, no, so it is not valid for a very large strain. And the conclusion, what we are getting from this, hot tensile test studies material behavior at high temperature. Yeah, definitely. Compared to normal tensile test, we are not studying upon at a high temperature how they behave, how the elongation. And I forgot to insert one point. Compared to normal tensile stress, the elongation of the hot tensile stress will be very higher. That means the ductility of the normal tensile stress is lower than the ductility of the hot tensile stress. Okay. Then essential for designing hot working process determines flow stress and hot ductility, and these all. Okay, now we are going to see an overall view of this hot tensile test. Hot tensile test, which is done at a high temperature greater than 0.5 TEM, which is a recrystallization temperature. Under this temperature, we are going to keep the furnace in the UTM machine. Under a furnace, we are going to give a temperature. In the temperature, we are going to calculate the elongation, reduction area, these and all, and it is used for rolling, forging, extrusion, turbine blades, these and all. And the procedure is standard tensile specimen is kept under now only I have said no, like that we have to maintain a uniform temperature, which is very important. In that we does not get a clear yield point. These are the important points you have to note in your examination, or you have to remember, which will help you in your work in your career. Okay. And the advantages, we can measure the specimen in a hot working conditions, which is very easiest and simplest method compared to industrial trials used for material selections and hot cracking. And we have oxidation must be low, maintaining uniform temperature also difficult. These are the limitations and conclusions. Hot tensile test studies material behavior at high temperature. Yeah, it studies material at high temperature, but a tensile test studies a behavior at room temperature. Note this point. That's all about hot tensile test. It is very simple and an easy topic. Thank you.